Hey guys, and welcome to this second video of the slope-intercept form of a linear equation. So let's get to it. Consider the equation w equals -6 plus 2k. Now at this point, we should feel very confident finding the ordered pairs for linear equations of this form. But now we want to talk about what their graphs look like. So first things first, let's create a table of values of ordered pairs for this equation. Since w is by itself, let's make that our dependent variable, and let's make k our independent variable. Now that we have the ordered pairs, the question is, how are these ordered pairs going to show up on our graph? Let's start with the point 0, -6. This is where the independent variable k is equal to 0. In fact, when we graph it, that's going to be our w-intercept. I like to think of this point as where our dependent variable starts when the independent variable is 0. Now, let's go ahead and graph the rest of these ordered pairs. Now, as we suspected due to our equation, they are in the shape of a line. But before we connect these points and draw our line, I want to draw our attention back to the table of values. Remember from before that because of this 2 in the equation, every time our k value went up by 1, our w value went up by 2. So, looking at the graph and starting at the w-intercept, every time the k value goes up by 1, that is, every time we move 1 unit to the right on our graph, it's no surprise that our w value goes up by 2. That is, move up by 2 units on our graph. And once we find that pattern, we can extrapolate in both directions. That number, 2, tells us how much our dependent variable changes for a 1 unit increase in our independent variable. That is, it tells us how much our graph goes up or down for every 1 unit we move to the right on our horizontal axis. So let's go ahead and connect our points and actually draw this line. Alright, now let's try graphing all the ordered pairs for 2y minus 8x equals 14. Now I'm wholly confident in your ability to put this into y equals form, find the ordered pairs for this equation, and graph the line. So why don't you pause the video and go ahead and do that. Alright, so there's our graph. Of course, the 7 in our equation told us that we'd have the ordered pair 0, 7, which is our y-intercept. So it's really nice to be able to find that point right away when you look at that equation. Of course, the 4 tells us that for every 1 unit increase in x, we'll have a 4 unit increase in y, which is the same thing as saying, when we zoom in on the graph, that for every 1 unit we move to the right on our graph, we move 4 units up. One other thing, whenever we're graphing lines, I think it's a good practice to always find our y-intercept and our x-intercept. Now looking at our graph, our x-intercept looks like it's really close to -2, but it doesn't actually look like it's on -2. And like I said before, if you can't be certain, don't eyeball it. So let's use the equation to find our x-intercept. Just substitute 0 in for y and then solve for x. So we see that our x-intercept is -7/4, which is -1 3/4, which is so close to -2, which is exactly what we thought it would be. Alright, now let's try graphing all the ordered pairs for the linear function f of x equals 8 minus 2x. Now note, we may see some function notation here, I just want to keep us comfortable with it. Note that this is the exact same thing as graphing y equals 8 minus 2x. So our strategy is going to be absolutely the exact same. And what's great about having this already in function notation or already in output equals form is that we've got our y-intercept staring at us in the face. Our y-intercept for this graph is going to be 8. So we can go ahead, before we do anything, we can already graph that ordered pair. What's also great is we have our slope, -2, staring at us right in the face. Which means for every 1 unit increase in x, we'll have a 2-unit decrease in y. Or equivalently, for every 1 unit we move to the right on our graph, we're going to move down 2 units. So we're probably all ready to graph this equation, but let's go ahead and find the table of values anyway, then graph it. And so we see with our slope of -2, for every 1 unit we move to the right, our graph goes down 2 units. And now, of course, once we find that pattern, we can use it and extrapolate farther. We had enough ordered pairs to draw our line anyway, but there wasn't anything keeping us from drawing any more ordered pairs that we knew would be on our line. Alright, I'm hoping that at this point we're feeling comfortable and confident enough with these equations that we can start to graph them without even making a table of values with ordered pairs. Of course, if you need, there's no problem quickly drawing up a table of values, but it would be very nice for us to get to the point where we look at an equation and we immediately know how to graph it. So here are 2 examples, y equals -5 plus 3x, and one in function notation, m of x equals -2 minus 5x, and from each of these you can find the y-intercept no problem and the slope no problem, and I urge you to try to use that information to graph each of these. Alright, from our first equation, that -5, we can already tell that's going to be our y-intercept, so we went ahead and plotted the point 0, -5, and our slope of 3 tells us that for every 1 unit to the right we go, for every 1 unit increase in x, we're going to have a 3-unit increase in y. So for every 1 unit we go right, we're going to have a 3 units up on our graph. And so we were able to use that pattern, extrapolate our points, and draw the graph. In our second example, that -2, we immediately knew that would be our y-intercept, so we went ahead and we graphed the y-intercept at 0, -2, and the slope of -5 meant that for a 1 unit increase in x, there would be a 5-unit decrease in y. For 1 unit we go to the right, we would go down 5 units, and we could extrapolate that pattern in either direction to find other points and create our graph. One note was that for both of these x-intercepts, we weren't able to find them just by looking at our graph, so we had to use the equation. Alright, 2 last examples to practice with. Now note that neither of these linear equations are in slope-intercept form, so you're going to have to put them into slope-intercept form, then find that intercept and use the slope to find some other points in your graph real quickly and graph them. So please do so, and we'll reconvene when you're done. One quick word of advice, when you're extrapolating that pattern in both directions, please create a whole bunch of points on your graph, a nice spread before you actually connect them and draw your line. If you have only a few, even if you know what the graph is going to look like, make those other points. It'll make your line more accurate. Alright, and to finish up, I like to use this graphing calculator software to do a little exploration of how changing the equation for a line in slope-intercept form changes how the line looks. So right now we've got y equals 0 plus 1x. The y-intercept is 0 right on the origin, and the slope is positive 1, meaning that every time we go to the right 1, we go up 1. Every time x increases by 1, y increases by 1. Now if we change the slope to 2, you can see how that changes the graph. Every 1 unit we go to the right, we go up 2 units. If we change the slope to 3, you can see how that changes the graph. If we change the slope to 4, you can see how it changes the graph, and of course 5. Now we have the same y-intercept, but for every 1 unit we go to the right, we now go up 5 units. And you can see that anytime we have a positive slope, our graph is going to go up as we read it from left to right. Of course, the greater the number, the higher in magnitude that number is, the steeper our graph is going to get. Of course, if we change the y-intercept, the slope isn't going to change, but the graph will shift up or down accordingly to make the y-intercept whatever that number may be. Now let's try some negative slopes. Of course, if our slope is negative, now our graph is going to slope downward as we read it from left to right. Of course, the larger the negative slope, the steeper our graph is going to be. Again, switching the y-intercept won't change the slope at all, it'll just shift our graph up or down accordingly to make that number the y-intercept. Alright guys, that's it for this video. I hope you found it helpful, and I hope you enjoyed.